1X just did something huge. Something that genuinely changes the trajectory of humanoid robotics as we know it. They've released a new AI model called Redwood, and it's not just an upgrade, it's a turning point. Because for the first time, 1X's flagship robot, Neo Gamma, can now operate autonomously in a real human environment. Not a lab, not a simulation. Your living room, your kitchen, your hallway. Neo doesn't need teleoperation. It doesn't need a carefully scripted command. With Redwood, it's learning from the real world, moving naturally, understanding its environment, and making intelligent decisions as it goes. You ask it for something, it fetches it. A door's in the way, it opens it. A path is blocked, it reroutes. This is end-to-end mobile manipulation at an entirely new level, and it's here now. Welcome back, guys. Alfie here, bringing you another groundbreaking update. 1X just changed AI robots forever. And it's kinda scary. You're watching the AI Nexus, and as always, we're here to bring you every step of the future. Let's go. What 1X has pulled off with Redwood isn't just impressive. It's a little bit scary in how fast it's progressing, how capable it already is, and how much it hints at where AI robots are headed in the very near future. Redwood isn't just another deep learning model tacked onto a robot brain. It's purpose-built to handle the real-world chaos of a human environment. That means dealing with unexpected objects, weird lighting, background noise, clutter, and all the little things that typically trip up robots outside controlled settings. And instead of being trained in a sanitized dataset bubble, Redwood is grounded in experience. It learns from the world, constantly updating its knowledge, behavior, and physical intelligence in real time. Now here's where it gets especially wild. Redwood is already powering Neo Gamma to do things that most robots today can only dream of. We're talking autonomous manipulation tasks like grabbing objects from shelves or countertops, handing them over to people, or placing them in containers. It can identify what's in its environment, plan a path to it, and move with the kind of flow that feels almost human. And remember, this isn't a mechanical arm bolted to a factory floor. This is a full mobile humanoid robot navigating your home. We've seen glimpses of this kind of tech from companies like Tesla, Figure AI, or Sanctuary AI. But what sets 1X apart is how seamlessly Redwood merges software and hardware into one fluid robotic system. They didn't just throw a smart brain into a dumb shell. Neo Gamma was built for this kind of intelligence. Its joints, limbs, and sensors were designed with safety, compliance, and natural motion in mind. Redwood simply brings that hardware to life in a way we haven't really seen until now. And the scariest part? It's not just good, it's already practical. In early demos, Neo Gamma shows how it can move across living spaces smoothly, avoid obstacles without hesitation, and carry out commands with zero telepresence help. The moment you see it gracefully turn a doorknob or reach for a box and hand it to someone, it hits you. We're not watching science fiction. We're watching the real thing. What 1X is building with Redwood is the next logical step toward general-purpose humanoid assistants that can live alongside us. Not as novelties, not as toys, but as actual helpers. Robotic counterparts that can take on household chores, care tasks, even light labor. And the speed at which Redwood enables this autonomy is where the conversation gets serious. Because Redwood's intelligence isn't just pre-coded or behavior-based, it's dynamic. It adapts, it learns. This is the same fundamental principle behind large language models like GPT, except applied to the physical world. Redwood is teaching Neo how to behave in human spaces, just like a child learns by watching and trying and adjusting. It sees what works. It sees what doesn't. It improves. This shift, from brittle automation to flexible physical AI, is massive, and the timing of it couldn't be more critical. Across the robotics industry, we're seeing a push toward what many are calling embodied AI, intelligence that doesn't just exist on a server or in the cloud, but one that lives inside machines that move, interact, and shape the world around them. Redwood is 1X's answer to this. And it's already proving that embodied intelligence isn't theoretical anymore. It's operational. Let's not forget, 1X has been building toward this for years. Back when they were known as Haloti Robotics, their initial systems focused on safe, compliant movement. They weren't trying to win headlines. They were trying to build robust foundations. That groundwork is now paying off in a major way. Because when Redwood dropped, it didn't just add AI to a robot. It activated a full robotic system that's ready to work in the same rooms we live in. The use cases here are endless. Think about elder care, where Neo could help with lifting objects, reaching things that are high up, or even just bringing water or medicine. Think about homes with mobility-challenged residents, where a robot like Neo could act as a second set of hands or feet. Think about busy households where Redwood-powered bots help with tidying, sorting, or even just taking care of repetitive tasks. And this is just the beginning. Because Redwood is designed to scale, it's not a one-off model for Neo Gamma alone. It's a foundational AI that can be iterated, trained further, and extended to other robot platforms down the line. Redwood doesn't just make Neo smarter, it sets a precedent. A proof point that deep learning, physical intelligence, and general-purpose robotics are converging now, not a decade from now. That brings us to an important question. How far can Redwood go? Right now, it's focused on home-level tasks, navigation, object manipulation, basic human-robot interaction. But with enough data and continued training, there's every reason to believe this same core intelligence could scale to more complex industrial or commercial scenarios. Warehouses, hospitals, hospitality, construction. The intelligence powering Redwood today could very well be the same kind of brain managing larger, more powerful humanoids in the future. And let's talk safety. One of the things that makes Redwood so viable is that it's deployed on a robot that's inherently designed to interact with people safely. Neo isn't a brute force industrial machine. It's a robot built for trust. That means compliant joints that don't jerk or slam, sensors that detect human presence and adjust movement accordingly, algorithms that prioritize user comfort and collision avoidance. In a way, 1X is doing what very few robotics companies have pulled off successfully, building trust in the machine. Not just with performance, but with behavior. Redwood doesn't make Neo feel more robotic. It actually makes it feel less robotic, more helpful, more aware, more capable of integrating into our lives without demanding that we change how we live. But of course, there are concerns. This level of autonomy in a robot brings up big questions about control, privacy, and safety. If a Redwood-powered robot can move through your home, access your belongings, and make decisions in real time, who sets the limits? What happens if it makes a mistake? How do we prevent misuse? These are serious conversations that need to happen alongside the innovation. Because once robots start living in our spaces, the implications extend far beyond tech. They become social, ethical, political. 1X seems to be aware of this, and they've taken a measured approach with their rollout. They're not blasting out thousands of Redwoods into the wild overnight. They're testing, evaluating, building carefully. And that restraint might be the most important part of this entire story because it shows that they're thinking long-term, not just chasing headlines. Still, the Redwood reveal marks a definitive moment in robotics. A before and after point. Before Redwood, the dream of general-purpose humanoid robots felt like something we were still inching toward. After Redwood, it feels like we've arrived at the edge of it. You don't need to imagine it anymore. You can watch it move. Watch it pick up a bottle, hand it to someone, open a door, and move through a home. Fluidly, safely, autonomously. Redwood is more than just a model. It's a message. That message? We're officially entering the era of physically capable AI robots. The kind that don't just process language or generate images, but the kind that can walk, grip, see, and serve. And 1X is no longer a quiet contender. They're now leading the charge. As we move forward, the Redwood platform will likely evolve rapidly. More behaviors, more context, more environments. And with it, Neo and potentially other humanoid robots will become even more intelligent, more adaptable, and more useful in daily life. Whether that excites you or gives you pause, one thing's certain. 1X just changed the game. And this time, it's not just the future of robotics. It's the future of how we live, work, and coexist with intelligent machines. While 1X's Redwood-powered Neo Gamma is redefining what embodied AI can achieve in real-world interactions, they're not alone. Another game-changer just stepped into the spotlight, and it's Figure AI. With almost no warning, they dropped a new demo that's sending shockwaves through the entire robotics world. And what this humanoid did? It's not only impressive, it might be the clearest glimpse yet of our automated future. Their humanoid robot, Figure 2, was captured performing one of the most complex tasks we've seen from a bipedal machine so far, autonomously scanning and sorting packages with real-world variability, including soft, deformable ones.
The second is the consumer household. So how do we do everyday things in the house, like do laundry, like put away dishes, clean up the kids' toys. So basically, we've designed the hardware to be able to do what like an average human can. And we rank this on like range of motion, torques and powers, like basically payloads and speeds. Can we basically like do what a human can physically?
Let's be clear. This isn't a staged handoff or a carefully scripted set of robotic motions. This is a robot operating in a real warehouse-like setting, making decisions on the fly, and using nothing but visual input and AI to guide its every move. Figure 02 identifies each package, determines its type and destination, and executes the correct motion, all with a level of smoothness, speed, and reliability that's closer than ever to human capability. What makes this even more groundbreaking is the fact that all of this is being powered by a single neural network. No complex rules-based programming, no manually tuned behaviors, just an AI model trained to take in raw camera frames and output physical actions, end to end. This is a seismic shift in robotics development. We're not just teaching robots how to move anymore. We're teaching them to decide how to move in real time, based on what they see.
With packages, it's really tough. In the case of like logistics work we're doing with small packages, every single package and every single instance of packages coming together is different for the robot every single time. And you cannot solve this with code.
You can't solve this with code.
You can't code your way out of this problem. It's impossible.
Brett Adcock, the CEO and founder of Figure, was crystal clear on this point. In his own words, you can't code your way out of this problem. The message is simple but powerful. Traditional robotics can't scale to solve real-world tasks at human-level dexterity. The only path forward is through AI-native solutions. And Figure is proving that in the most concrete way imaginable. This demo isn't about robots in the abstract. It's not about sci-fi dreams or speculative future projections. It's about what's happening right now. Robots understanding the world, planning their actions, and executing them, all in a unified loop without human micromanagement. And they're doing it at a pace that's accelerating faster than most people realize. Let's talk about the motion, because if you haven't seen the video yet, it's honestly mesmerizing. The way Figure 02 picks up both rigid and soft packages, scans barcodes, and sorts them efficiently looks more like a human warehouse worker than a clunky robot arm from the past. The transitions are fluid. The grip adjustments are subtle and dynamic. The machine isn't just performing a sequence, it's perceiving, adapting, and completing tasks with genuine awareness of its environment. This might seem like a small step from the outside, just moving boxes, right? But in robotics, this is a massive leap. Especially when you're dealing with deformable objects, which don't behave predictably. Unlike a plastic bin or a metal tool, a padded envelope doesn't always rest the same way. It might sag, fold, or bounce. So for a robot to not only recognize it but handle it appropriately without crushing or fumbling, that's a milestone. And here's the kicker. This is just the beginning. Brett Adcock didn't stop at showcasing what Figure 02 can do today. He also unveiled details about their next-generation robot, Figure 03, and the headline number is jaw-dropping. Figure 03 is projected to be 93% cheaper than Figure 02. Not 9, not 30, 93. That level of cost reduction doesn't just open the door to mass adoption, it kicks the door wide open. For comparison, think about what happened with smartphones. The first iPhones were expensive, experimental, and limited in capability. But as production scaled and technology matured, the cost dropped dramatically. And suddenly, smartphones were everywhere. Now imagine that same curve, but with humanoid robots. That's the trajectory Figure is aiming for, and with Figure 03, they're signaling that they're well on their way. Adcock was clear about the broader ambition. The company is well capitalized to support massive scaling. They're preparing to train large-scale models, roll out industrial-strength inference pipelines, and eventually produce hundreds of thousands of humanoid robots. That's not just for show. That's a long-term, economically viable vision. And it means Figure is thinking far beyond flashy demos. Still, what's interesting is their philosophy on growth. Despite the bold vision and massive scale potential, Figure isn't trying to balloon into a corporate giant overnight. Instead, they're keeping their team lean, nimble, and innovation-focused. They're prioritizing speed, agility, and iteration, qualities that often get lost when companies scale too fast. And that might be one of the smartest decisions they've made. Let's rewind a bit. A few years ago, the idea of a general-purpose humanoid robot doing useful work in unstructured environments seemed far off. Even the most advanced bots struggled with stairs, dropped items, or couldn't handle any task outside a predefined script. But Figure is blowing past those limitations by treating robotics not as a mechanical problem, but as a data problem. This is where that single neural network becomes so important. In traditional robotics, you build a system from the ground up with separate components for vision, control, motion planning, object recognition, and so on. But the future is end-to-end learning. Feed the robot raw data, let it learn the patterns, and trust the neural net to figure out the rest. It's exactly what happened with large language models like ChatGPT, except now we're seeing the physical equivalent. And the reason this works now, when it didn't before, is because the compute power, data infrastructure, and model architectures have finally caught up. Figure is building robots with AI brains trained on massive real-world data. Every movement, every interaction, every edge case becomes part of a growing dataset that feeds back into smarter, more capable robots. It's a virtuous cycle, and it scales fast. That's also why the cost reduction is so important. As Figure brings down the price of each robot, they can deploy more units in the real world. More deployments mean more data. More data means better models. Better models make the robots more useful. And as usefulness increases, so does demand. It's the same feedback loop that turned the iPhone from a curiosity into a necessity. And Figure wants to do the same for humanoids. Now, let's not sugarcoat this. There are still challenges ahead. Humanoid robots operate in environments that are incredibly variable. Unlike factory robots that bolt parts together on an assembly line, humanoids need to deal with chaotic, messy, real-world settings. That includes everything from uneven floors and changing lighting conditions to human coworkers and unexpected obstacles. But Figure's approach, AI-first, neural network-driven, and data-intensive, is uniquely positioned to tackle those complexities. And when you think about where this could go, it's hard not to get excited. Imagine warehouses staffed by robots that never get tired, homes assisted by bots that understand your needs, and industries where labor bottlenecks are eased by safe, reliable automation. These aren't futuristic fantasies anymore. They're rapidly becoming viable economic realities. We're now seeing a convergence point in AI and robotics that few anticipated arriving this quickly. Figure is right at the heart of that convergence. They're not just building a robot, they're building an entire platform for intelligent embodied agents. That platform will learn, adapt, scale, and ultimately integrate into everyday life. And here's the wildest part. It's happening in front of us in real time. Every few months, Figure drops a new demo, and each one feels like a leap forward. But this latest video is something else entirely. It's the clearest signal yet that humanoid robotics has left the realm of theory and stepped into practical, scalable execution. The implications of this go far beyond logistics. Sure, sorting packages is a great test case. It's repetitive, high volume, and commercially relevant. But if a humanoid robot can do that task with end-to-end autonomy, what else can it learn to do? Office support, elder care, manufacturing assistance, disaster response? The applications are endless. And with AI at the core, every new use case just becomes another opportunity to improve the model. We're not just watching a robot sort boxes. We're witnessing the birth of a scalable digital worker, an embodied AI system that can be taught, deployed, refined, and upgraded without rebuilding hardware or rewriting code. That's the dream, and Figure is closer to realizing it than anyone thought possible. So, while most of the world is still catching up, Figure is quietly rewriting the rules of what robots can do. And if this latest breakthrough is any indication, we're in for a future where intelligent, autonomous humanoids are not just part of science fiction, they're part of everyday life. Keep your eyes on Figure. Because what they just did, it wasn't just impressive. It was the future, arriving a little earlier than expected.